Chapter 16, Marine and Coastal Systems and Resources. Turn to page 421. So the case study here is about the Atlantic cod, which is a famous situation where a fish basically declined so much that they had to stop fishing for it. So Atlantic cod is found off the coast of New England and Nova Scotia. It was hugely abundant for fishing. It created the wealth of the United States, actually, in the colonial times and onward. It funded the Revolutionary War, and unfortunately, the industry has ties to the slave trade. Okay, so now new fishing technology in the 1980s caused a population crash. And so they had to close the fishing grounds, which caused a loss of money and a loss of jobs. So those are the economic impact of the cod collapse. Now this is a famous case study, which is why we're sticky noting it. All right, let's talk about the ocean. All right, you need to know here on page 422 this figure and parts of the ocean. And so you have the continental shelf, slope, rise, an oceanic ridge. This is a divergent plate boundary, so the plates go this way and they go apart from each other. Here's a trench, this subducting and causing a volcanic island arch. This is a review from chapter 2 a little bit, at least these two parts. You need to know about ocean water that it's about 3.5% salt, which is 3.5% is equal to 35 parts per thousand. So you need to know that salinity is lower near the equator due to a lot of rain, which dilutes it. It's higher around us, so we are at 34 degrees north latitude because we don't get a lot of rain, but we have a lot of heat, so it evaporates. And so water's high heat capacity. Basically, it takes a lot of energy to heat and water, and it takes a lot of energy removed to cool water, and that basically influences coastal climates. So you will notice that out here, if it's 110 degrees in Santa Clarita in July, what do? We go to the beach because at Ventura it's 70 degrees, and that has to do with the coastal influence, the ocean influence on climate. We don't get that oceanic influence on our climate because we're behind 2 mountain ranges from the ocean. So we don't get that nice temperature consistency. On page 424, there's a picture of all the currents. The main two that you need to know is the Gulf Stream. The Gulf Stream brings warm water from the Caribbean up along the east coast, and it actually shoots over here. So if you look way up here, England is pretty high in latitude. It's actually really far north. But it's actually warmer in the winter than Minnesota, which is further south. And that has to do with the warm water shooting across here and making this climate down here warmer. And this is really the only way that people can live in Northern Europe. It has to do with the influence of the Gulf Stream. The California current is important because it brings down nutrients. It brings down cold water from Alaska, so we have a cold current, not a warm one. And it's also involved in upwelling, which you need to know over here on 425. So the steps of upwelling, basically, the wind blows down the coast, but because of the Coriolis effect, which is the spin of the earth, surface water moves away from land. And so if water's moving away on the surface, water from below is coming up, and that is upwelling. Know the 3 steps of upwelling. Now this is super important because upwelling brings nutrients which start the food chain. And so anytime you have upwelling, you have nutrients from here that hit the light, and now you've got a plankton bloom because plankton are producers, phytoplankton are producers, and they need nutrients and they need light. If nutrients are here and light's here, that's a problem. But when nutrients come from below to the top, now you've got nutrients, light, and now your phytoplankton can bloom and be happy. And then your animals that eat plankton can be happy, and then your sharks move in and your sea lions move in, and everybody's happy. And upwelling is extremely important. So upwelling. Most life in the ocean is near the coasts due to upwelling and in the photic zone because of photosynthesis. So photic zone is the top zone of the ocean. Downwelling is the opposite of upwelling. Know what thermohaline is and know what enso is. Now enso is El Nino, so refer to the learning cycle that we did when you are studying about El Nino. Here's some figures of what happens with El Nino. So just kind of a review. So normally, here's Peru, here's Asia. Normally the winds blow this way and it's blowing away from the coast, and so water from below comes up to replace it. And so you have huge amounts of upwelling normally, which creates good fishing. Good plankton, good fishing. So this is a normal situation, and then the water gets pushed this way and creates this pool of warm water along the equator here in Asia. Now this pool of warm water creates lots of rains and creates a lot of monsoons and big rain in Asia. Okay, about every 5 to 7 years or so, those winds die off. They stop pushing the water, and then the water starts coming back this way. It takes several months to travel back the other way. And so we end up with warm water off our coast and here and there. And that warm water fuels storms, which then give us a ton of rain. But the fishing stops, and so it's bad for fishermen because upwelling stops. So know this figure and caption and the steps in normal Pacific Ocean circulation and El Nino circulation. Extremely important to know these things. Study it a lot. Page 426. There are certain zones in the ocean. These are the ones that you have to know. The photic zone, basically where there's light near the top. The intertidal zone is like here with the tide pools, where it's really harsh conditions here. You have a lot of wave action. At low tide, those critters are exposed to warmth and getting dried out, and so they have to have extreme adaptations to survive in these extreme circumstances in the intertidal zone. The pelagic zone is kind of just the free swimming zone, just kind of in the middle, just swimming around. And then the benthic zone is at the bottom of the ocean. Okay, ocean acidification is a real problem. It's kind of decimating coral populations right now. All right, so what happens is this. Ocean acidification occurs when carbon dioxide from burning fossil fuels dissolves into ocean water. And this reacts to make carbonic acid. So the carbonic acid is H2CO3, know that. Well, carbonic acid lowers the pH in the water. It's an acid. And so certain shells with now, some critters in the ocean have shells made out of calcium carbonate, CaCO3, like corals, and they begin to dissolve in the more acidic water. We're talking about just slightly higher levels of acid. It's not like huge drop in pH. It's a slight drop in pH, but it's enough to erode the shells. Page 430, we have some of our ecosystems in the ocean. We have salt marshes here and mangrove forests. Salt marshes are found in the temperate zone, which is us. Our wetlands near the ocean are saltwater, salt marshes, because we are in a temperate zone. Down in Florida and Louisiana, they're tropical, and so they have mangrove forests. Know how they benefit ecologically and economically. So these are some types of wetlands, and they're really important. They protect against storm surges, They protect, they provide huge amounts of productivity for food chains. That's an ecological benefit. And so just make sure that you read through this section and you read through this section and memorize how they benefit ecologically and economically. You need to know that an estuary is a wetland where a river meets the ocean, and it has brackish water that's part salty, part fresh. Now, in an estuary, like a salt marsh or a mangrove forest or an estuary, the salt levels vary. Sometimes the salt levels will be high when it's high tide or lots of waves. The salt levels will lower when there's lots of rain for fresh water to dilute the salt levels. So understand that. Page 431, you need to know about corals. That's another ecosystem. So coral are tropical, mainly tropical, and they have a mutualistic relationship with zooxanthellae, which is an algae. Now, zooxanthellae are sensitive to temperature and pollution and can leave the coral. So if the temperature is too hot or there's too much pollution in the ocean, they leave, and the zooxanthellae provide the color. And so when the zooxanthellae leave, the coral dies and it gets bleached out. It's not bleached, but it looks white because it's dead. And that's because the zooxanthellae algae has died off. Benefits of coral? Well, huge amounts of biodiversity with coral reefs. It's also a nursery for fish, baby fish. Coral reefs absorb wave energy to protect coastlines. They provide tourism. People go out and snorkel and bring money into a community. Our threats to coral include fishing techniques that scrape the coral. The coral is cut for shipping, so that sometimes a coral reef surrounds an island or kind of blocks a port, and so they cut the coral reef to let ships through. And then sewage and toxins, and then I forgot to add, actually here, I'm going to add it right now, ocean acidification. All right, 432. Go on to 433. All right, so marine pollution is a huge issue. We have lots of trash. So we have here some pictures of showing you the trash in the ocean, and it's kind of circulating through these gyres, which are circular currents, into these big patches called the Great Pacific Garbage Patch. So please know the effects of the Great Pacific Garbage Patch in the middle of the Pacific, and also there's one in the Atlantic, but the one in the Pacific's bigger. Toxins are released from plastic. Little bits choke them out. It's really not good. It's kind of just disturbing. Here's a scientist who studied the Great Pacific Garbage Patch and kind of saw where it moved over time. It's enormous. I mean, look at the scale, the size of that. It's pretty crazy. Next page, page 436. So here we have oil pollution. Okay, the Deepwater Horizon was an oil platform. It's the most recent oil pollution situation. It happened in the Gulf of Mexico, and it spilled huge millions and millions of gallons of crude oil into the Gulf of Mexico over a couple of months till they could fix it. And it was pretty devastating to the Gulf of Mexico ecosystems. Know what the U.S. Oil Pollution Act of 1990 is. The provisions basically said that you have to have ships that are double-hulled instead of singled, and that's because of a spill from the Exxon Valdez that happened in Alaska. And then over here, know the graph. Now, a lot of people think most of the oil in the ocean comes from oil spills. It's actually natural seeps. Like in Carpinteria, we have natural oil that turns into tar seeping out of cracks in the ground. So most of it is natural. We'll continue on with the next video.